This video serves as an introduction to your Chapter 6, Section 3. It's basically just reviewing linear functions. There is a warm-up. I'd like you to pause the video and attempt identifying the slope of these two graphs and hit play when you're ready. So if we're looking at the first graph, I want to point out that the scale is 1. So this is a 2 here and a 1 here and a 2 here, so on and so forth. When I ask you to identify slope, there's a couple of different ways that you could do that. The first way is just using m, by the way, signifies slope, rise over run, or slope also is equivalent to y2 minus y1 over x2 minus x1. I gave you 2 points. There was a point here, which is located at 0, 2, and there's a point here, which is located at 1, negative 1. If I'm using rise over run, to get from this point to this point, I can see that I need to move right 1 unit and then down 3 units. Moving right is a positive movement, left is a negative movement, moving down is a negative movement, and moving up would have been a positive movement. Oops, sorry. So the positive 1 and a negative 3 would go into my rise over run. Rise would be the negative 3 over my run, which is 1. So rise is the vertical distance and run is the horizontal distance. And then I could simplify, if need be, making the slope negative 3. You could have also plugged it into this equation. Like I said, it would be 2 minus negative 1, and then 0 minus 1. And you'll see that gives me 3 over negative 1, or negative 3. I think it's easier just to use rise over 1, but it's completely up to you. All right, the next one, we have a point at 0, negative 1, and then we also have a point here at 5, 1. Rise is up 2, which is a positive movement. And then run is right 5, so that's a positive movement as well. If I'm doing rise over run, that would be 2 over 5. Also, it's worth pointing out that I could have also went from this point to this point. It's just that we tend to read left to right. But if I was going from this point to this point, right to left, it would have been down 2 and left 5. Which would be negative 2 over negative 5, which is still 2 over 5. A couple things I want to point out. Slope-intercept form is y equals mx plus b. Hopefully you remember that from your Algebra 1 days. M represents the slope, and b is the y-intercept. If you were to have a vertical line, so that's something that looks like this, then that would be x equals some number. If you were to have a horizontal line, that would look like y equals some number. And we're going to see examples of this later on. For now, we're going to take a look at example 1, which is just identifying the slope and the y-intercept by looking at an equation. So if the form is y equals mx plus b, then m is going to be 2, and then b is going to be a negative 3, because I need to keep that sign. Part b, once again, y equals mx plus b, so m is here, it's negative 7/3, and b is 4. Being able to identify this information will help us to graph. We can see step 1 is to identify the y-intercept, plot the point on the graph, and step 2 is from this point use the slope. So we have y-intercept and slope helping us graph. Starting with example 2, part A, the slope is -1/3, and then the y-intercept is 4. So the first thing I'm going to do is plot my y-intercept at 4. So 1, 2, 3, 4. I went up 4 because it was a positive. If it would have been -4, I would have gone down 4. So that's my first point. To get my second point, I'm going to use the slope. Remember, it's rise over run. So I could use this negative to go to the rise or the run. I'll show you both ways. So let's say I want to put the negative with the 1. That means I'm going to move down 1 and right 3. Because that's a negative movement and then a positive. Or I could have moved up 1 and left 3. Really, you only need 2 points in order to draw a line, but the more points that you plot, the more accurate it's going to be. So I'm going to start from here. I'm just going to keep going down 1, right 3 a couple more times. And then I can go up 1, left 3 a couple more times. So that way when I draw my line, it can appear to be straighter than when I would have just freehanded it. All right, part B. Let's try that one. So M is going to be 2 or 2 over 1. So I'm going to go up 2 and right 1, or down 2 and left 1 would be another way I could do it, because 2 negatives would give me that positive slope still. And then B is going to be -2. So I'm going to plot my y-intercept at -2 first, and then use the slope to get a second point. Up 2, right 1, or again, I could have went down 2, left 1. You could at this point draw your line, but I'm just going to keep plotting some points. So that way, when I draw my line, it's a bit more accurate. Okay, part C. Again, it's y equals mx plus b. So the 5/2 belongs with the x, meaning that this is my slope. And there's nothing here. So whenever there's nothing written for the y-intercept, it's assumed to be 0. So the y-intercept will be here at the origin, at 0, 0. And then I'm going to use the slope to get another point. 5 over 2, so 1, 2, 3, 4, 5 up and 2 to the right. And I'm just going to do it one more time. Or I could have went 2 negative movements, because that would still give me a positive slope. So down 5, right 2, down 5, right 2. Not the best at drawing straight lines. That's why I like to plot more points. Okay. Part D. What would the graph of y equals -3 look like? Oops, I don't know why it's frozen. Okay, I think I got it fixed. So, on a coordinate plane, I have y equals -3. So y means it's going to be along the y-axis, and because it's negative, I'm going to go down. So 1, 2, 3. It's -3. If I have the function y equals -3, that means y will always be -3. So it's always going to be -3. No matter what x value I have, I'm going to go down to -3. So what would the graph of y equals -3 looks like? It will be a horizontal line that passes through -3. If it would have said x equals -3, it would have been a vertical line on the left-hand side, going left 3.